You don't have this slide in yours, but that's okay. It's one word. Interference. All right, the final two major elements in this unit. Well, there are a couple other ones, but yeah, the big two elements that we look at from here on out deal with the wave phenomenon of interference. We've talked about interference. Specifically, we've talked about constructive and destructive interference. Hopefully that jogs your memory a little bit. And it talks about when two waves are at the same place at the same time, we say they can superimpose. So that means they end up at, at the same place at the same time, and they can interfere when they do that. Okay? Now, how they interfere depends a lot on the following idea. It depends a lot on what we call phase. Now, you've heard about this, I am almost sure of it, in math. All right? And so when we talk about phase, we talk about, and I talk about the part of a wave or what a certain part of a wave is doing at a certain instant. Okay? So, for example, if we look at points A and C, relative to equilibrium, they're both in the exact same position. Well, again, relative to equilibrium. All right? So since they're both peaks, we say they are what we call in phase. A and B, however, are exactly in the opposite sort of displacement from equilibrium. We call those out of phase. All right. Now they happen to be A and B completely out of phase. All right. Or well, there's different ways to actually say that. Okay. Now, even though A and C are in phase, well, they're not exactly this. They're not the same peak. So if we think of, I wish I had another. I'm going to try this. Hang on. Watch this. Bear with me, folks. Yeah. Keep. Oops. No. Yep. Copy. Get over here. This will take forever. Thanks for your patience. I probably could have paused while we did this. I can tell you another story if you'd like. We've heard lots of stories today. Come on. Ah, perfect. Now, if this is a sine or cosine wave, it doesn't matter which one. Well, check it out. Oh, wait. Yeah, fine. Clone. Good. Notice, if we take this wave, and, well, remember that a full wave for us, if it's a cosine or sine wave, this represents 360 degrees or 2 pi radians, right? So if we take one of these waves and we shift it, we can shift it until it's lined up again with the other one, or what we say, till it's in phase again with the other one. Well, and how much do we have to shift it to get it all the way back in phase? We had to shift it over 360 degrees. Okay? So we say that these two waves, we could say that these two waves, or we could just say that this point and this point have a phase difference of 360 degrees. Phase difference of 360 degrees, or 2 pi radians. A and B, well, how far do we have to shift to go from here to here? That's half a wave. So we could even also say this. We could say a phase difference of 1 wavelength, or 360 degrees, or 2 pi radians. Here we could say there's a phase difference of half a wavelength, or 180 degrees, or pi radians. What about points C and D? Well, here's C, here's D. Well, that's how much of a wave? That's a quarter of a wavelength. So a phase difference of lambda over 4, or 90 degrees. or that would be pi over 2 radians. All right, so there's lots of ways to talk about the difference in phase between 2 points on a wave. Okay? Okay, now, if we look at 2 waves, like we did, on the other slide, we say that these 2 waves here are completely in phase. Right, so we could have 2 points on a wave, like points A and C, that are in phase, or really 360 degrees out of phase, which is actually in phase. Or we could say for 2 different waves, well, these are in phase because peaks line up with peaks, troughs line up with troughs. Now, 2 waves that are in phase, how are they going to interfere? They would interfere constructively. Fair enough? Notice these 2 blue waves here are, well, troughs lined up with troughs. So 2 ways we can say this. We can say they are completely, that's the kind of qualifier, these are completely out of phase. Or we could say they're 180 degrees out of phase. Or again, pi radians, or half a wavelength out of phase. Just like over here, we could say that these 2, it's hard to tell if they're, we could say that they're 0 degrees out of phase. Or, hard to tell, maybe they're 360 degrees out of phase. Or maybe they're 720 degrees. Or maybe they're 4 pi radians. Or maybe they're, there's lots of different ways to say it. But the big deal is that these are in phase, interfere constructively. These are out of phase. They will interfere destructively. Fair enough? Okay? Okay. Now, let's look at a situation like this. What do we have here with these 2 this one green wave and this one blue wave? What we have are 2 waves. Well, we got 2 waves. All right? And what you notice, I hope, is that there are some places like this where they are in phase. And there's another place where they're in phase. There are places like this where they are out of phase, completely out of phase. And like this, completely out of phase. And like this, completely out of phase. Dot, dot, dot. So these 2 waves, it seems like they vary, or they, what's the word I'm looking for? Alternate between being out of phase and then in phase and then out of phase and then in phase and then out of phase and so on and so on and so on. And the question is, why does that happen? Well, it happens, if you notice, because, well, if we look at the frequency of wave 1, frequency is typically measured in cycles per second. I'm going to do, I don't know, let's call this, let's say this is measured in seconds. And the green wave has, let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 waves. 10 per 15. So 2/3 of a hertz. Fair enough? The blue wave, let's see, has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 waves in 15 seconds. Or, so this is what? 0.67 hertz. This is 0.80 hertz. Right? Now, beat frequency, blah, blah, blah. What's that mean? Well, if we literally look at the addition of these 2 waves, I mean, if we actually find how they superimpose, or, we said before, right, we get a wave pulse like this. Come on, where are you? Oh, because I'm using the eraser. We get a wave pulse like this, get a pulse like that, right? We literally just add this amplitude and that amplitude. So, like, well, I don't know, right here, since they're out of phase, their sum is about nothing, right? And like right here, their sum is about that much. Each of them is at, 5, whatever units those are. And here, each of them are at like, I don't know, 6 units, so maybe the sum is 1.2. And here, each of them is at like, 7.5, so the sum's like 15. And here, each of them is like an 8, so the sum's like 16. And here, it's big again, like 16. And here, so notice, I'm just adding up every place where I see an intersect. It's going to be back like that, and here's going to be, like that. And here's going to be like, I don't know, like that. And so on, and so on, and so on. Right? So we go from being nothing, so we sort of see a shape that looks like this, right? Comes back down here where they're, they add up to nothing there, and then it gets real big again and sort of does that. So we end up with this sort of shape like this. And the next slide is actually, literally, in Excel, I plotted these two green and blue ones and then said, add up those, every value for each of them, and what do you get? And that's what you get. Okay? So what these two things are, the green and the blue, are like two sounds with slightly different frequencies. And what you hear when you play those two sounds is you hear the red thing. And if these are sounds, it goes from low amplitude to big amplitude to low amplitude to big amplitude to low amplitude to big amplitude and so on and so on. And you hear this thing, it goes wow, 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 wow. You've heard it before, maybe. We'll play it for you tomorrow. Jeffrey's gonna bring in that electric guitar of his tomorrow. Play some more. What is it you play, dude? Like Death, Slayer, Festival. What was that? Like something so. Yeah. Anyway, bring that electric guitar in again, Jeffrey. But yeah, we hear this sound that goes wow, 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 and we hear things called beats. We hear things called beats. All right, and each one of the wow, wow, each one of those is called a beat. So remember, the frequency of wave 1 was, what did we say, 10 in 15? And the frequency of wave 2 was 12 in 15? Well, how many beats do we have in 15? 1, 2. So in general, we can talk about beat frequency. That. Beat frequency. And beat frequency that we call F beat is the absolute value of the difference between the two frequencies of the things that you're playing at the same time. We can show this really well with tuning forks and the microphone. Unfortunately, you can't hear those real well. All right, but there are ways that we can have you hear it. Really neat sound. All right, those are called beats. Okay, and again, when do beats happen? When waves of different frequencies interfere alternatingly, constructively, and then destructively, and then constructively, and then destructively, constructively, and blah blah blah. Okay. I think, yeah, that's really it for today. Am I recording this even? I hope so. I haven't seen that little recorder. I think I am. Oh yeah, there it is. I am. Good. That's good. So, yeah, okay. So that's, what we're getting into right here is that two waves are interfering, and how do they interfere? All right, our next segment, where it starts to get tricky, I'll tell you, is when we have here two sources of waves that also interfere, and how do they interfere? Well, that depends. All right, depends on, a few things. All right, so this gets neat, but it's based in this idea of two things interfering. Okay? Not really any problems to solve here, folks, because here's the whole math. This is just like sort of, maybe part 1, multiple choice. What's the beat frequency of two different frequencies? All right, we'll make sure we can play this sound for you tomorrow. We'll go over some lens questions tomorrow, the homework that you have. And we have put on the calendar for next Tuesday, that would be a week from today, the 19th, a test on everything up to lenses, up to and including lenses. Okay? All right, folks. Sleep in tomorrow. Lucky people you.